So hello everyone, today we are going to discuss about how to set a particular bit in a given number. So here we are going to write that how to set a particular bit given number. Okay, so here we are using C language, so I am going to select language C and I am removing the default statements. So first of all, our input is going to be the particular number what we are going to take. So let it take input is 36 and I want to make the particular position bit is going to be 3. The position 3 of a number is going to be set. So how to set a bit? So the main option is how to set a bit is if any bit, suppose I am going to have an operation. So I am having 0 1 0 1. This is my binary number, and if I want to make the particular bit position the least significant bit, LSB is 1 here, and this is, we will call it as position 0, and the next bit is position 1, position 2, position 3, and so on. So now I want to make, suppose position 1, that is position 1 is having an number as 0. So if I want to make that position 1 as 0, so must and should I have to make OR operation. So bitwise OR operation I have to make, so to make it 0. So that means what I have to make OR operation, it has to be 1 has to be come here and the remaining bits are 0. Let it take like this. Okay, so 0 0 1 0. So whichever position, suppose the position 1 is 0, so for that particular position only I have to make OR operation with 1. So remaining all the bits should be unaltered. So then only I can able to get the result as suppose this 1 I am going to left shifted by 1 time. So when 1 is going to be left shifted by 1 time, then only the result 0 0 1 0 will come. So the result is going to be what? The result is going to be 0 or with 0 is 0 0 1 1 1. So this is the result what I am going to get if I am making OR operation. So 1 0 1 OR with 0 is 1 and 0 OR with 1 is 1 1 OR with 0 is 1. So this is the result what I need to get. So now I am going to do the same operation in the type of program here. So I am going to call it as a mask. So I'm going to take an integer variable mask. So what is that mask operation? That whichever operation, that means how many times the one has to be shifted. So one is going to be left shifted by how many times? 3 times. So why? Because I am going to select the position as 3 over here. So the mask bit is going to be 1 over here. Mask is going equal to 1 left shifted by position number of times. So what is the result then? So the result is going to be int result is equal to, so whatever the number I am going to take num or with the mask operation. So this is the result what we are going to have. So here I am going to print the given number as well as printf the input is percentage d. Okay, percentage d and comma, what is the number? I am going to take that, and similarly I am going to print the result also. So the output is percentage d and the result is going to be result I am going to have here, and I am going to do the run operation over here. So here the position is undeclared. Okay, so here we are given the position, so 1. Okay, so here it has been renamed, it is in the position form. So the input is 36 and the output is 44 here I am getting. So here I am going to give a next line printf, uh, so printf slash n I am going to give, so that I am going to get in two different lines what is the input and what is the output here I am going to get here. Okay, So now I'm going to get, so the input is 36 I am getting and the output is 44 I am getting. So but whether it is correct or not I don't know. So for that I need to uh, represent this input as well as output in binary representation, then only I will come to know that whether it is correct or not. So for this purpose I am going to take one more function. So I'm going to include one function, that is show show binary. This is a function I am going to take over here, show binary of number. So whatever the input I am going to take, so I have taken that, and similarly I am going to use the same function show binary to see the output. So here I am representing show binary as result. So now I am going to write that function, how to represent a given number in binary format. So int show binary of integer x, I am going to take some variable input parameter, whatever the number input number it will give or the result you are going to pass, it will be stored as an x. Okay, so now I am going to represent. So how to represent a binary number? So generally in a 64-bit system, uh, the integer variable is going to take uh, 4 bytes. So 4 bytes means what? How many bits? 32 bits. So if I am going to start with position 0, so 0 to 31 positions. So totally 0 to 31 means 32 bit positions will be there. So now I am going to write a condition how to print whether 1 or 0 for entire 32 bit representation. I am going to write an if condition statement over here. So if the given number, so suppose if I am giving input as num, so the num it is going to be taken over here if x and with, that is bitwise and operation, one left shifted with. Okay, so before to this I am going to run a loop now for 32 times. So for that, for uh, I'm going to write one more declaration over here, integer I. So for int I equal to 31, I greater than or equal to 0, I minus minus. So why I am taken I equal to 31 means totally I am going to have 32 bit representation. So 31 is the most significant bit and 0 is the least significant bit. So 1 here it is going to be shifted by uh, 32 times. So totally from 0 to 31 times it is going to be shifted. So 31 I am going to shifted here. So that means what? 1 will come to the last position. Suppose if my 31st bit representation, let it be take for an example, triple one triple zero. So this is an 8 bit, 1 2 3 4 5 6 7 8, and 0 double 1 0 1 1 2 3 4 5 6 7 8, and 0 1 1 0 triple 1 0. This is one more 8 bit, and 110011. So here I am going to have totally 32 bit representation. So whenever it is going to be initialized with I equal to 31 and 1 left shifted by 31 means what? 1 will come over here. So this 1 is going to be shifted by 31 times. So 1 is going to be come here and check with the most significant bit. So 1 is going to be come here and check with the most significant bit whether this particular bit is 1 or not. Suppose now here I am having the most significant bit as 1. So 1 and with 1 is what? 1. So the if statement is true. So then it has to be print 1. Suppose if the most significant bit is 0, if the most significant bit is 0, then 0 and with 1 is what? It is going to be 0. So then it is a, then it has to be printed 0. So that's why here I am going to give a statement like that. If x and with 1 left shifted by I times, if the condition is true, okay, then what it has to be print? It has to be print as 1. Okay, else there is no need of braces also over here. Why? Because here I am going to use a single statement. So else printf 0 is going to be printed. Okay, So that's it. So that means what, the 1 is going to be come over here to the most significant bit and check. So if the most significant bit is 1, then the output is 1. So 1 is going to be printed. Suppose if 0 is there in the most significant bit, so 0 and with 1 is what, 0. So then if condition is going to be false, then 0 is going to be printed. So like that, 1 is going to be come to the next position here. uh, why? Because I equal to 31, then I equal to 30. Why? Because I is decremented by 1. So like that, 1 is going to be left shifted by 31, 30, 29 and so on. 1 left shifted with 0, that means last 0th position, so that it is going to be print the binary format. So this is the logic what we are going to uh, written over here. And as we have a user a function, so we have to give a declaration before using the function call. So here I am going to use in show binary int, so there is no need of declaration. And this is the binary representation what we are having, show binary, the output is. So we'll just run it, we'll check what is the output here. Giving error, expected declaration at end of input 37. So what is it? Okay, so here we are enclosed the for loop. So here I am getting this output statement, printf show binary result, and printf the output is okay. Here I will write a printf and again over here, so that I am going to get a clear output representation. Okay. Now the output is okay. Show binary result here I have given, and the binary representation also I am getting over here, and the output is here I am getting the result. And here one more statement I am going to give and make it run. Okay, now see here, we are going to get the input is 36 and the output is 44. So input 36 representation is what, 001001. So this is the representation, binary representation what we are going to get. And what is your what is our main aim, that set a particular bit in a given number. So the question might be asked like set a particular bit position of position 3 or position 4, something like that. Here I have taken position 3. So position 3 is what here, position 0 is 0, position 1 is 0, position 2 is 1, and position 3 is 0 over here. But see the output. So the output is same as that of the input. uh, Least significant bit is 0 here, here also it is 0, and the next position 1 is 0 here, here also 0, position 2 is 1 here, and here also the position is 1. But here the position 3 is 0, but it has been changed to 1 over here. So the remaining bits and all, it is going to be the same over here, the input and output. So the problem statement is given by like anything. So the only one thing what we have to do is make an or operation with a 1. So if we are making or operation with 1, then that particular bit position is going to be set. So this is the process how we have to set a particular bit. So the simple note is, if you want to set a particular bit, make or operation, make bitwise or operation with 1. Okay, so this is the simple fundamental what we have to know if you want to set any particular bit. That means if any particular bit is 0, we can make it as 1. So if we want to make it as 1, shift that 1 to a particular position. So this is what all about a setting a particular bit. Thank you.